Ferrari just released data in Bahrain that made rival teams stop their simulations mid-session. Not because they were quick, because they were terrifyingly quick in a way nobody expected. 1 lap. 1 minute 34.273. 4/10 clear. Nearly 200 meters gained on the straight before anyone else even reached peak speed. 200 meters. That is not incremental progress. That is domination. But here is the part that changes everything. The SF26 did that while still showing visible energy clipping at the end of the straight. Which means this car is not even optimized yet. It is already the fastest over 1 lap. And it is still unfinished. Add to that a brand new V-shaped diffuser generating massive downforce. An aggressive hybrid deployment strategy no one else matched. And an active aero system now under FIA review. This is not a normal testing headline. This is a potential championship shift. Because if Ferrari fixes the energy smoothing before the first race, the gap could grow. And that possibility is exactly why engineers across the paddock are suddenly very quiet. Subscribe now. Because once we break down what really happened on day 2 in Bahrain, you will understand why this was not just testing. It was a warning. Let's break down exactly why that lap sent shockwaves through the paddock. Because it was not just fast. It was structured aggression. When Charles Leclerc set that 1 minute 34.273, every team immediately pulled the sector data. And what they saw in Sector 1 changed the tone of the entire day. The SF26 did not gradually build speed down the straight. It exploded. The acceleration curve was steeper than anyone else's. Ferrari deployed electrical power earlier and harder. The car reached peak velocity almost 200 meters before the Red Bull. 200 meters. That is a lifetime in Formula 1. That means Ferrari is front-loading energy deployment. They are choosing to dominate the first half of the straight. Why is that important? Because in modern Formula 1, the first half of the straight determines everything. If you surge early, you force the car behind into defensive mode. You control the braking zone. You dictate positioning. Over a single lap, that strategy is devastating. But here is the detail that has engineers thinking long-term. After that violent surge, the Ferrari begins to taper. Energy clipping appears before the braking zone. The hybrid assistance fades earlier than rivals. So what does that tell us? It tells us the battery draw is aggressive. Very aggressive. Ferrari is sacrificing sustained deployment for peak impact. And that works perfectly in qualifying simulations. 1 lap. Maximum output. No compromise. But in race trim, deployment must be balanced. If you burn energy too early lap after lap, you are forced into lift and coast. You become vulnerable at the end of straights. And here is the part that really unsettles the grid. If this clipping is primarily a software mapping issue, it can be corrected quickly. Torque curves can be smoothed. Deployment timing can be refined. Energy recovery rates can be optimized. Meaning this weakness might not be permanent. So rival teams are not celebrating Ferrari's clipping. They are calculating how dangerous the car becomes once it is fixed. Because if Ferrari maintains that early straight-line dominance while extending deployment deeper into the straight, the gap does not shrink. It grows. And that is why Block 1 of Day 2 was not just a fast lap. It was a demonstration of ceiling. A glimpse of how high this concept can go. And we have not even reached the long-run data yet. Now we move to the part that truly divided the paddock. The long runs. Because raw pace creates headlines. Race simulations create reality. Lewis Hamilton stepped into the car for the afternoon session. Higher fuel, hotter track conditions, a proper race distance program. And immediately, the tone shifted. The Ferrari was still quick, but it was not calm. Out of slow corners, the torque delivery felt sharp, almost abrupt. The rear tires had to absorb a sudden surge of electrical power. Then halfway down the straight, that surge faded earlier than expected. Strong, then flat. Over 1 lap, you can manage that. Over 50 laps, it becomes exhausting. Because a driver depends on rhythm, on predictable braking points, on consistent throttle response. And when the energy deployment changes mid-straight, braking markers shift. Confidence erodes. Here is where things get serious. The hybrid system appears to be draining aggressively under full attack. That explains the explosive Sector 1 we discussed earlier. But it also explains the visible clipping at the end of longer stints. And in race trim, you cannot afford that pattern. You cannot afford to defend brilliantly for 3 laps and then suddenly become vulnerable on the straight. Red Bull will not hesitate. McLaren will not hesitate. Now add another variable. The SF26 operates within a very narrow aerodynamic window. When ride height is perfect, the V-shaped diffuser generates massive downforce. The car looks planted, precise, almost effortless. But when crosswinds hit, Or when the car attacks a curb aggressively. Airflow can stall momentarily. Rear grip drops without warning. That is not a slow car. That is a sensitive one. And sensitivity becomes magnified over long runs. Because tire degradation increases when torque delivery is abrupt. Battery temperature rises when deployment is aggressive. And both drivers begin asking for adjustments. Hamilton wants smoother torque. More predictable entry stability. Leclerc is comfortable closer to the edge. He extracts speed from rotation. This is where internal tension begins to matter. Every change to calm the rear reduces the sharpness that created the headline lap. Every adjustment to protect the battery reduces the early straight surge. Ferrari is balancing peak speed against sustainability. And that is a delicate equation. Now imagine this scenario. The clipping is primarily software related. Mapping adjustments smooth torque delivery. Energy deployment becomes more progressive. Suddenly the rear tires last longer. The braking references stabilize. And the qualifying advantage remains. If that happens, the long-run weakness disappears quickly. That is why rival teams are not dismissing Ferrari's issues. They are studying them. Because this does not look like a structural flaw. It looks like a car operating close to its limit. And cars like that, once refined, become dominant. Day 2 was not about proving Ferrari is perfect. It was about revealing how high the performance ceiling really is. And that ceiling looks higher than anyone expected. But the long-run data was only half the shock. Because while engineers were debating energy curves and tire degradation, something else was happening quietly in the background. The FIA cameras were not just recording laps. They were studying behavior. Specifically, the Ferrari front wing and floor edge under high-speed load. And this is where tension escalated. At maximum velocity, the front wing elements appeared to flex in a very controlled way. Not dramatically. Not obviously illegal. But enough to raise questions. The 2026 regulations are extremely strict about movable aerodynamic devices. Drag reduction is allowed within defined systems. But generating additional cornering stability through movement is a completely different conversation. Rival teams noticed that in fast corners, the Ferrari looked unusually stable for a car with such an aggressive diffuser. Almost as if the platform was being supported aerodynamically. If that front wing is subtly adjusting under load to maintain balance, that becomes a powerful advantage. Because stability at high speed allows drivers to carry more entry speed. And more entry speed translates directly into lap time. Now imagine combining that with the early straight-line surge we already discussed. Explosive acceleration. High downforce when the ride height is perfect. And potential aerodynamic stabilization at speed. That is not a coincidence. That is architecture. The FIA is reviewing footage closely. If the system is deemed compliant, Ferrari retains a massive conceptual edge. If adjustments are required, the operating window narrows even further. And remember, this car already lives on a narrow window. Add to this the revised floor specification introduced on day 2. More curvature at the edge. A repositioned support stay to manage flexibility. These changes increase total load, contributing to Leclerc's benchmark lap. But more load also increases drag. And more drag demands more hybrid energy to maintain straight-line speed. Everything connects back to the same central theme. This Ferrari is pushing boundaries. Aerodynamic boundaries. Hybrid deployment boundaries. Setup boundaries between two elite drivers. That is why teams were shocked. Not because Ferrari is flawless. But because the potential is enormous. If the torque delivery is smoothed. If the clipping is minimized. If the aero interpretation passes scrutiny. Then the SF26 becomes a complete weapon. Qualifying dominance. Elite slow corner traction from the S-duct airflow management. Massive diffuser load. And controlled high-speed stability. That combination wins championships. But here is the final tension building quietly in Bahrain. Development speed. Ferrari does not need perfection on day 2. They only need to prove their ceiling is higher than everyone else's. Because over a season, the team that refines fastest usually wins. And after day 2, the data suggests Ferrari's ceiling might be the highest on the grid. That is what truly shocked Formula 1. Not the lap time. Not the radio frustration. But the realization that if this concept matures quickly, the balance of power could shift before the first race even begins. Now we reach the part that could define everything. Day 3. Because testing headlines are emotional. Race simulations are unforgiving. Ferrari ends day 2 with the fastest lap. But also with the biggest question marks. And the entire paddock knows what is coming next. A full race distance run. Battery temperatures monitored in real time. Rear tire degradation measured lap after lap. Energy deployment adjusted corner by corner. This is where the truth surfaces. If the SF26 completes a race simulation without overheating the battery, without excessive lift and coast, without sudden rear instability as fuel burns off, then the fear becomes real. Because that means the weaknesses are manageable. And the strengths are authentic. But if the clipping reappears consistently, if torque spikes continue destroying rear tires, if crosswinds expose the narrow aerodynamic window, then the narrative changes instantly. From potential dominance to fragile brilliance. And here is why that distinction matters. Ferrari does not need to be perfect in February. They need to show that the core concept works. And on day 2, they showed something undeniable. The SF26 has pole position pace. It has exceptional slow corner traction. It has a diffuser capable of generating enormous downforce when conditions are correct. And it has a hybrid system willing to deploy aggressively enough to shock the grid. Those are not small attributes. Those are championship ingredients. The only question is whether they can combine them without compromise. Because right now, everything feels slightly on the edge. The aero balance. The energy strategy. The driver preferences. It is a car operating near its maximum limit. And cars like that are dangerous in 2 ways. They can collapse under pressure. Or they can become unstoppable once refined. Rival teams are not reacting emotionally. They are reacting analytically. They see a concept with a very high ceiling. And in modern Formula 1, ceiling is everything. You can fix software. You can adjust mapping.